thousands of years, bronze has been a cornerstone of human innovation, and today, in the world of high-precision manufacturing, it's far from obsolete. In fact, its unique properties make it utterly irreplaceable for critical components.
Hi everyone, welcome back to the channel. Whether you are a design engineer, a seasoned machinist, or a hobbyist, getting the most out of the bronze can be tricky. Its self-lubricating nature, excellent wear resistance, and corrosion resistance are amazing, but they require a specific approach. Today, we are breaking down everything from choosing the right alloy to mastering the cut. Let's get started.
So why is bronze such a superstar in CNC machining? First, machinability, wear resistance, and corrosion resistance. Its high ductility and failure hardness allow tools to cut in smoothly and uniformly. This makes achieving high accuracy and complex geometry easier, avoids tool damage and instant tool life. Its excellent wear resistance makes parts sustain very little wear under extended friction, making it perfect for bearings, bushings, and gears. And finally, its great corrosion resistance stands up to water, steam, chemicals, and even seawater. Many alloys are also self-lubricating, reducing the risk of failure where lubrication is impossible. Not all bronze is created equal. Your first and most critical step is choosing the right alloy for your application. Here's a quick guide for simple bronze: excellent wear resistance, high strength, and good elasticity. Perfect for high-load bearings and springs. Processing tape: use sharp tools with high cutting space and long to medium feed rates to avoid hardening. Thin bronze: excellent corrosion resistance, especially against seawater. Great for valves and pump cases. Tape: it has excellent machinability. Just keep tools sharp and use them with coolant. Aluminum bronze: this is the strength champion. Highest strength, corrosion, and high temperature resistance. Tip: it's abrasive. Use rigid machines with resistant carbide tools and low speeds with slow feeds. Lead bronze: the king of self-lubrication and vibration resistance. Very easy to cut. Major tip: due to its lead content, dust collection and safety protection are absolutely critical. Silicon bronze offers high strength, excellent corrosion resistance, and is non-sparking. Tip: it's gummy and can produce long chips. You must use chip breaker tools to prevent entanglement. Mastering bronze machining hinges on 3 pillars: tool selection, cutting perimeters, and coolant. 1. Tool selection: always use sharp positive break constant carbide tools. K-type carbide is suitable for most bronzes. A dull tool is your worst enemy. It will cause work hardening. 2. Cutting perimeters: a good rule of thumb is high cutting speed with moderate or low feed rates. High speeds ensure good chip formation, while proper feed rates prevent a build-up edge and guarantee a great finish. 3. Coolant use: never skip coolant. A water-soluble emulsion is highly recommended. It removes heat to avoid deformation and instantly washes away chips to prevent them from scratching your masterpiece. Even with a grip pen, issues can pop up. Here's how to solve them. Problem 1. Premature tool wear. Problem with aluminum bronze. Solution: use tougher carbide tools and ensure effective coolant injection. Problem 2. Low surface finish, caused by dull tools, high feed, or vibration. Solution: use sharp tools, reduce feed rate, and check your workpiece clamp-in rigidity. Problem 3. Work hardening happens when a dull tool rubs instead of cuts. Solution: use a sharp tool and appropriate depth of cut to get under the hardened layer. The job isn't done when the part comes off the machine. Post-processing enhances properties and aesthetics. Deburring and polishing. Methods like vibratory or magnetic polishing remove microscopic burrs. For mirror finish, electro polishing is key. Sandblasting creates a uniform matte finish, enhances texture, and camouflages machining marks. Theory is great, but how does this work in practice? Let's look at a real case. A ship builder needed an ultra-high precision bronze Velocron for seawater use. Challenge was achieving perfect sealing in high-pressure, salty water. LS Precision solution was to use high-tin bronze for its superb seawater resistance. They used multi-axis CNC for micron-level consistency, optimized the tool path for a near finish, and integrated an online measurement system for 100% quality control. The result? A level that exceeded performance requirements and significantly extended maintenance intervals. Cost is always a factor. The main influences are material type. Aluminum bronze is more expensive than fossil bronze. Tolerance and surface finish. Tighter tolerances and smoother finishes cost more. Only specify them where absolutely critical. Order quantity. Larger volumes reduce the unit cost. Post-processing. Each added process adds cost. The best cost control strategy starts in the design phase. Optimize your design for manufacturability. Bronze versus brass. Bronze is stronger, more wear, and corrosion-resistant, ideal for heavy-duty parts. Brass is softer, cheaper, and great for decorative or general components. Minimum tolerance. With high-end CNC, tolerances is less than or equal to 0.001 mm are achievable, but it depends on the part geometry. How to get a code? The easiest way is through online platforms like LS Precision. Just upload your 3D model, and their system gives you an instant, detailed code. Bronze is a strategic material for creating high reliability, long-life parts. By understanding its properties, choosing the right alloy, and applying these best practices, you can fully leverage its enormous potential.